The first question is which rules is or are associated with the chapters that you read? Why are the rules important, and how do they relate to resources and resource allocation in general?
Okay, so in chapter 8, and both chapter 9, it mentions like this regulation and how important it is for like humans to not be doing too much, like not producing so many toxins that go into the waters, which produces algae, too much pesticides in our fields, too much poaching of lions and like sharks, and yeah, and like this kind of correlates to like not having too much or too little, because as a result of that, like other populations of other organisms tend to like be, I don't know, it tends to just like affect them.
Yeah, I think for chapter 8, it's also about the population's density is what regulates the species, and so it's important because predator and prey need to be equal, and also it relates to resources and resource allocation in general, because like an example was the Cambodian rice farmers, where they got rid of plant hoppers by bombarding them with pesticides, but the outbreak continued because um, the pesticide ended up increasing the plant hopper's density, and because the plant hoppers evolved resistance and increased the rate of egg laying by 2.54. Yeah. And
Nice.
then
And then
for chapter 9, I put that species can be regulated by human management, and this is important because management of one species affects a chain of different species, and so this relates because, like in chapter 9, there were wolves were released in Yellowstone, and large elk populations decreased, and this reduced the browsing of elk, allows the willow to flourish, and more willow shrubs are now available for beavers to use in their dams, and beaver populations increased.
okay, nice. Okay, so for question 2, what were the challenges experienced by the scientists mentioned in the chapters? How did these challenges impact their learning, both positive and negative consequences? How do the research support the rule of the chapter? So, um, in chapter 9, Kitchell and Addis, they kind of ran into like a political risk that threatened their current project. So like they wanted to experiment on the large lake in an urban setting, and this required tens of thousands of people and required like the opinions of others, because it was such a big project that will affect other people, and it it was the opinions mattered because it was such it could either be a waste of money or worse, or like a waste of fish, and some people didn't kind of like it, and um, kind of like the local fishermen, they they wanted to like do this project because it was gonna obviously affect their company, and they decided to put some of their own money into like this experiment. And this example ties perfectly to the last paragraph of the chapter. We might expect then that the more altered an ecosystem is, the harder it will be to restore it. So,
For chapter 8, I thought that Charles Peterson was a good scientist to talk about because, like, his challenge was that the base scallop fishermen started pulling up large numbers of cow-nose rays in their trawl and pun nets, and the rays started getting entangled and damaging the nets, and because of their poisonous barbs and like their lack of commercial market, like they became a nuisance for the fishermen, and this impacted um, Charles Peterson's learning positively because they found that cow-nose ray population expanded tenfold, but it impacted his learning negatively because they found that because of the absence, it was uh, the ray's dense population caused the absence of scallops, and also like the increase in the rays was caused by the decrease in sharks because of like fishing with sharks. Yep. For question 3, it is, in looking at water as a finite resource, how does water correlate to the resources that were discussed in chapter 8? How do they correlate with the resources discussed in chapter 9?
And first,
Wait.
whoever.
Okay, I'll go first. For chapter 8, I found that like water correlated to the resources discussed in chapter 8 because the bodies of water can easily be disrupted because of humans' tendency to pollute and mismanage it. So, for example, the reason why the Clean Water Act of 1972 was instated was because of the pollution levels in Lake Erie and promoted an effort to reduce the loads of chemicals that were being dumped and washed into the Great Lakes by humans.
Okay, yeah. I wrote something similar to that. It was like in chapter 9 and chapter 8. The Clean Water Act was like discussed in 1972, and because of the large algae algae populations on water, they decided to make that. And for example, an example is Lake Erie was full of tiny single-celled blue-green algae called microcystis. These algae formed thick mats that covered many miles of lake surfaces, and this algae blocked many organisms from like functioning, which disrupted like an whole ecosystem which was under the lake. And molecular biologists use these terms to describe components that are required for a system to work and those that are able to generate some outcome by themselves.
Next question.
Yeah.
Connect an example for one chapter to another, and how does this example further the author's perspective and our understanding of the rules?
Okay. So in chapter 8, it talks about the topic of like having too much or too little of a population, and it talks about how the scallop population was declining as a result of rays and sharks, and because too many sharks were being poached or fished, it resulted in an increase of cow-nose rays, which decreased the population of the scallops. And a similar case is in chapter 9, where in chapter 9 where where the people wanted there was too little fish in Lake Tuesday, so they wanted to bring more fish because there was an increasing population of minnows, and these kind of correlate to like the topic or to the rule of everything needs to be like balanced. Or yeah.
Yeah. So for my partner found this for like they also found a connection between the bubonic plague and the wolves and willows, and it was really similar to your example where like one of the species increased and the other species declined, and so like this helps us understand the role of regulation and its impact on different populations, and like predators and prey need to be equal in order for all the populations to sustainably thrive.
Okay. Number 5. How does dysregulation of the rules lead to issues? Think of the examples in the chapter as what would happen if the same dysregulation occurred for finite resources such as fresh water.
So I thought that dysregulation of the rules lead to issues because it affects the population of species that affects the population of other species, and like it's a whole butterfly effect.
Yeah.
And an example of this was in chapter 8 where olive baboons in Ghana were started to raid fields of crops, and like the groups of baboons started to strip strands of plants and severely damaging many others. And this was due to like all of but one species of baboons, which were the olive baboons, becoming locally extinct, and also it was due to like the olive baboons' main predators, which are lions and leopards, populations plummeting.
Okay. Oh, you done?
If this dysregulation occurs in freshwater, then we would have an even smaller amount of fresh water to use for consumption and push us faster towards a water deficit.
Okay. I wrote something similar of saying how they need to be equal to each other and not having too much or too little, and I stated about the lakes and the bodies of water which have, if too many toxins are released into the waters, algae blooms will occur, which can affect the whole lake and ecosystem under the lake, and it's like a domino effect. So if it affects one, it'll affect the other, and in the same way, if the same dysregulation happened to water, it would be like very difficult to get these toxins out of the water, which can affect the population of the people.
And then, question 6.
Yeah.
In many places in the world, fresh water is limited or even non-existent, due to pollution, dysregulation, and misuse. How is it possible to fix what is broken, design a solution that could support the care, rejuvenation, and restoration of fresh water? Be specific and think about why your solution is viable and realistic.
Okay. A solution to support the care, rejuvenation, and restoration of fresh water is the drip irrigation system, and this system delivers water to plants and other vegetations like directly instead of wasting unnecessary water in a way that keeps the roots moist but not soaked.
And then, a solution that I found is like improving irrigation and agricultural uses of water. An example of this is irrigation scheduling, which is deciding when and how much water to apply to a field instead of irrigation tactics such as flood irrigating. We can apply the exact amount of water needed to replenish the soil, and this saves water and energy, and it's just like more efficient. There's also like a few solutions that like everyone can do, such as washing full loads of laundry, taking shorter showers, using water at night, and unplugging the power appliances that uses water. Yeah.
Okay.